of function evaluation and compositions. First of all, let's talk about function notation very briefly. Instead of writing down an output, we are more specific now of writing function notation. F at x or f of x is actually function notation that replaces the output y. The x represents the input. The f represents the name of the function that we're using. The parentheses here do not mean to multiply, even though it looks like it's multiplication. We're used to having multiplication represented by brackets. It does not mean to multiply here. And so the whole thing, f at x together, is an output. X is a dummy variable. It could be replaced with any letter as an input. For example, we can have h of t. So t could be time, is the input inside a function named h. So h could represent height. So height is the whole thing though. So think h of t together is height, and time is just being specified that that's the input variable. So let's do some examples. We have a function f as a set of some points, and the function g is a set of some points. And we're asked to find f of 1 first of all. So f of 1 means we're looking for the output or the y value if x is 1. So let's start off by locating in the function f. So looking through the points of function f, we're going to locate where x is 1. Here it is. And we need to find the y value of this point, which is -1. So the answer here is -1. Similarly, g of -1, you locate the point -1 in the function g, where x is -1, and look for the y value of that point. -2 is the answer. The next one, I'd like to talk about this notation first of all. When we have g circle f, this is like g composed with f. So composition is written with an open circle or not filled in circle. This means actually g of f of 1. So it's evaluated. So we need to find 1 inside of f, find the output, then put that inside of g and find the next output. So f of 1 we found from before, and we can replace it. And then g of -1 we also found from before, and so we can replace it. So final answer here is -2. Something to be careful of, notation for multiplication could also be written with a circle. Some textbooks use this for multiplication as well. So just pay attention to compositions are not filled in circle, okay? So the next question here is multiplication of outputs for the same x. So you have to be careful with this question and the one over here. We have to make sure that we're multiplying the outputs for the same x. If you look at your points, not all the x's are shared between f and g. Only some points are shared. I'm going to highlight them. This point has a shared x. This point has a shared x. And right here, these points. So we were going to have 3 values in our set, or 3 points in our set here. For our final answer, we're going to find when f multiplies with g. So we're going to keep the same x's, so -1, 0, and 2. And we're going to locate the new output, which comes from multiplication of output of f and g. So let's look at -1. First of all, we're going to take these two outputs, the y values, and multiply them, and we have an answer of -2. You do the same thing for 0. You multiply the outputs of these 2 points, and you get a 0. And then the last one also multiply -3, and this 2 right here. The y values get multiplied, and we get -6. For subtraction, same idea. We want to subtract the outputs for the same input x. So I'm going to write down my points this way. So I'm still going to have -1 with some sort of output, 0 with some sort of output, and 2 with some sort of output. So this time we're subtracting f minus g. So we're going to do the top output y, subtract the bottom one, -2. So we have 1 minus -2 would be +3. Same thing with the input of 0. So output subtracted 0 minus 2 would be -2. And then subtracting the outputs for the last pair of points. We have -3 subtract 2, -5. So we have a set of points for this. Notice the difference. Here we have evaluation at a particular point, so there's only one output for this. This is a function with x, meaning we're going to actually have a set of points, just like at the beginning we had a set of points for the function. We have less points just because the operation of multiplication cannot be done unless the inputs are the same. Let's do a few more examples. So the next set of examples, we have actually the same points f and g. I just have a brand new set of instructions here. So starting with the very first one, remember f circle g is just f composed with g and then evaluated at 0. So I'm going to rewrite it again, f of g of 0. So we're thinking about the input of 0 in the function of g. So here's my function g. I'm going to locate the point that has x as 0. There it is. The output is 2. So f of 2 is what we want to find now. So now we're looking at 2 being the input inside of function f. So look at function f points, locate 2, and look at the output from that. We get -3. Second question here, same idea. We have f composed with g, now at a different point. You should try this, pause the video, and then continue to see if you got it, okay? So we have f of g of -1. So g of -1, we go to the function g, locate -1 as the x, the output is -2. And then f of -2, we locate -2 as the x in the function f, so here it is, and the output is 3. You might think that this and this is the same. It is not. The order of composition matters. So here we had f as an outer function. Here we have g as an outer function. So let's see what this will be. So g of f of -1. So f of -1, go to -1 point in function f. Output is 1. It's g of 1. And then locate 1 as x in the function of g. It's not there. So this cannot be even evaluated. I would say it's undefined. Okay. Next thing, we have not a particular input x. It's left as general x. So again, in here, just like the ones we've done before, we're going to have a set of points here. All right. So remember what this notation means. It means we're taking f is the outer function, g is the inner one. So we're going to locate all the inputs of g first of all. So we're going to start with all the inputs of g. I'm going to have a point that starts with -3 to begin with, because that's the inside of function g. I'm going to find out what the output is from this g. So the output from the g is 1. I'm not going to record that just yet because this 1 is still inside of function f. So I'm going to locate number 1 in function f, which is here, and the final output is -1. So final answer is -1. Let me see if I can explain it in another way. Think about the input x under the function of g gives you an output g of x. And then we need to apply another function f over top of that to get the final result. So doing it with this point, we have the function, the x value that we start with is -3. We apply function g to it, or find the output under g. So the output under g we said was 1. So this is 1 now. And then this is the new input inside of function f. So we're going to locate this as the brand new x inside of function f. So function f has an x over here. So we're looking for the output of that. And we get -1. What you begin with is your x. What you end up with is your y value of the point. So we're going to repeat that up all the way until we're done all the inputs of g, because that's what it's saying here. x inside of g. So all the possible x's inside of g. Okay, so I'm going to erase this and I'm going to do this again with the new points. So the new x to start with is the next point, -1. So I'm going to start with -1, comma. So I'll do the rough work again for this time. So we have -1. Under operation g, we get an output of -2. So this is brand new input inside function f now. So -2 is over here. The output we get is 3. So what you start with is the x of the point. What you end with, the final output, is 3. That's the final answer up on the point here. So I'm going to erase this and do the next 2 points without all that work. Just follow along with me. So comma, the next point. We're going on the list. We have 0 as the next input. So you start with 0. 0 under function g gives you an output of 2. So locate 2 in function f and find the output of that is -3. Final answer is 0, -3. We have another point. The next point is 2. Next input 2. The 2 gives you an output of 2. So once again, you locate 2 in the function f and look for its output, which is -3. And last point, 3 goes to 1 and 1 goes to -1. So 3 goes to -1 overall. We're going to repeat this just for practice with a different order. So this is applying function f first and then applying function g. In other words, if you write it in a different way, it's g of f of x. So once again, we're going to have several points. This time we're starting with all the inputs, or all possible inputs x of f. So we're going to go through the list of f values of x. So all of these x's we're going to begin with all the time, and then find the corresponding y values, if possible, after we apply f and apply g. Okay, so starting with -2 is the first x value that's possible to input inside of f. So here the output is 3, and we locate 3 on g, and the output is 1. Next point is -1. So locate -1 in f, the output is 1, and then we're looking for 1 in function g. It's not there, so I can't actually do this point. I'll move on to the next one. 0. 0 goes to 0, and then in function g, 0 goes to 2. So overall is 0 to 2. Next point, 1. So remember, we're just going through the list of all possible x's inside of function f. So starting with 1, the output is -1. And then applying function g to that, we have -1 goes to -2. And I think this is my last point, starting with 2. 2 under function f goes to -3 as an output. Locate -3 in function g and look for its output, and we get a 1. So I hope you found this helpful, and I might do some more examples in another video.